section 2.6, we're going to look at combining transformations. So a quick reminder of different types of transformations that you've already met in the past. So the first one, we're going to look at translations. So you can have the translations along the x-axis. So it's involving y equals f of x plus a. So this is through the vector translation by vector along the x-axis, and it's minus a 0. So when it's along the x-axis and things are happening to x, the opposite happens. So you might be thinking, I'm adding a units to x, so I'll be shifting right if a is positive. In fact, you'll be shifting left. So for example, if y is equal to f of x and I want to do the transformation f of x minus 3, then that means I shift everything 3 units right. So I'm shifting or translating the graph by the vector 3, 0. For the translation to the left, I would have to be adding a number. So let's say plus 4, and that means I'm going to shift through minus 4, 0 vector. Now, if we're talking about translation along, so this was translation along the x-axis. Now, if we want to talk about the translation along the y-axis, then we are talking about f of x, and you add a to that f of x outside. So this is translation by the vector 0a. So that means we are going to shift it up a units, and if a is positive, and down if a is negative. So this goes along the y-axis. So for example, if I have the graph of f of x and I want to minus 3 from that, that means all the y coordinates need to be reduced by 3. So altogether we'll be going down 3. Okay, so these are translations. So you also need to know what stretches are. So stretches or enlargements along one of the axes. So the first one will go along the x-axis. So if you multiply the x inside the bracket by a, that will represent a stretch along the x-axis. So a horizontal stretch by factor of 1 over a. So why is that 1 over a? So it's inside the bracket. It's opposite thing happens to x's. If you multiply it by a, it means all the x's are going to be divided by a. So you divide by a. So if you think about it, you want everything to be happening a times as fast. So that means it will be squashed, the graph will be squashed lots of times. Now, if you want to talk about the stretch along the y-axis, a will be outside f of x, and that means you are going to do a stretch along the y-axis. This time by the scale factor, by the scale factor of a. So this time you'll be multiplying, it's vertically by a, so it's vertical stretch. if you know the lion story from last year, whenever things are happening in the bracket, you could imagine this is a lion inside the cage, and he's a bit unhappy, he's awkward, he's lying horizontally because he's so tired and really, really sad. So he just wants to sleep all the time, and he will be very awkward. He wants to do the opposite. So if you tell him, come on, lion, go 3 units left, he will do the opposite. He will move 3 units right. If you tell him, go a unit right, he will do opposite. He will go a units left. Now, if you think about, again, this lion inside the cage, if you tell him, come on, lion, I know you are tired, but make yourself twice as big, lots of times as big, he does the opposite. He curls up to become smaller. Okay, so opposite things happens because this lion is not very happy. Now, if you're talking about the outside, things affecting y values, again, you can think about the lion. So he is the lion, f of x is the lion, and he is outside in the freedom. So it's nothing is happening there that he doesn't want to happen. So if you tell him, come on, lion, go a unit up, he will happily go a branches higher up if he's outside. If you tell him to go a branches down, he will go a branches down. Now, if you tell him, come on, lion, make yourself twice as big, stretch yourself, obviously he's outside, so he's standing tall, he's not lying flat and being sad, he's going to stretch himself up, make himself twice as big, for example. Okay, now the 2 remaining transformations are y equals f of minus x. So here again, you can think about this lion being horizontally lying in the cage, and this is going to be both minus x and minus f of x are reflections of flipping. So what he does, he flips horizontally from one side to the other. So this one will be reflection in the y-axis, because the only way he can swap, he said, going from this end of the cage to that end if you reflect it in the y-axis. Now, if you're talking about minus f of x, so this time he's outside, he's very happy, he does somersault. Remember, he's standing tall, he goes on upside down. So you're going to have this kind of flipping. So this is reflection in the x-axis. There you go. So now we're going to have a go at example 20, horizontal flip. Okay, so here we've got example 20. We've got a function. I've drawn it 4 times because I'm going to transform it in 4 different ways. So the whole section is about combining 2 transformations. So over here we've got y equals 2f of x minus 1. So the 2 of f of x refers to 2 outside. The line is outside. You tell him to double in size, he will do so. And so you will be timesing everything by 2 along the y-axis, and then minus 1 is outside, so you will move everything down 1 unit. So you're going to stretch this graph with a factor of 2. So what will happen to this point here, it will go to 2 minus 2. This one will go to 6, 8. So we'll go to 6, 8. And this one will go to 2 minus 2. And this point will stay as it is. And this will, these on the x-axis will, the stretching won't affect them. However, if you move them, everything now 1 unit down, this will go over here. This point here went from 2 minus 2, now it will go to 2 minus 3. And this point used to be at 6, 8, now it's moved. So let's say 6, 8 was actually here. It's gone down to 6, 7. Okay, now this point, anything on the x-axis will go 1 down. There you go. And then the shape is very similar. slightly stretched. There you go. So I can definitely say that this point here, if I knew what the coordinates were, then whatever x coordinate and -1, whatever the x coordinate -1, but we're only interested in those 2 points. So this is going to be your A dash, and this is B dash. Then part B, we have f of x plus 2 plus 2. So now inside the bracket, you tell him to go 2 to the right. He does the opposite. He does 2 left, but outside tells you to go 2 up. So we want to shift the graph 2 left. Oh, sorry, this point was -0, -1. 2 to the left and 2 up. So 2 to the left, 2 up somewhere here. This one from -2 will go onto the y-axis. 2 up will go to 0, 1. And this one, 2 across, will go to 4. And 2 up will go to 6. So 4, 6. And we need to draw the graph like this one here. Maybe this one will go a little bit higher. There you go. No, that was the minimum. There you go. So this point here was the minimum A. So this is A dash double dash goes to 0, 1, and B double dash goes to 4, 6. Part C, a quarter outside means we're going to squash it vertically, factor of 4, and then 2 inside we're going to squash it horizontally by the factor of 2. So we halve everything and then find a quarter. So if we make this one smaller by a quarter, that will go to 2 minus a quarter. So this, let's triple dash, will go to 2, not 2, the y value will go to minus a quarter to begin with. Let's just do it slowly. And then this one will go to 6, 1. So we don't know yet the x's, but we will go to 1. Now we are going to squash the x's by the factor of 2. So it used to be at 2, now it will go to 1. And this one was at 3, at 6, now we'll go to 3. So it's somewhere here, and that will go somewhere here. And this one was at 0, 0. So we are going to leave it as it is, because if you halve it and quarter it, it still stays there. So it'll be squashed. And something like that. There you go. So that will be, there you go. Okay, and finally we've got minus outside, so that's going to be the flip in the x-axis, and -1, you tell him to go 1 left, but he's going 1 right. So we need to shift everything. Well, let's reflect it first. Let's reflect it there first. We'll go there, and this one will go over here. So it will go to -6 minus 4 to 1, but then we need to move it 1 across. So first of all, A goes to 2, 1, and then we'll move it 1 across. So it will go to 3, 1, and B goes to 6 minus 4, moving it across, goes to 7 minus 4. There you go. This one here will go to 1. So A for Ivy will go to 3, 1, and B will go to 7 minus 4. Okay, Okay, one more example, example 21. So over here we've got the graph of ln x, and we need to sketch y equals 2 f of x. So ln x, it should be a graph that you need to draw automatically. When x is equal to 0, that is going to be the asymptote, and ln 1 is 0, and it's an increasing function for x defined for positive x's, and it's always it's an increasing, so it turns to infinity, but incredibly slowly. So if I want to stretch it by the factor of 2, so that means I'm going to get a slightly stretched graph. So it's going to go slightly steeper graph. So times the y value. So if that was, let's imagine that was for that value, maybe it was whatever 1 square here. So now if you times that by 2, it's going further away. So just does this. Still goes through 1, but this one here goes slightly steeper. There you go. So this is 2 ln x. And then you've got y equals to modulus of f of minus of x. So let's just do it slowly. Let's do a tiny graph first. So this is ln x. Now f of minus of x is going to be the same as reflection in y-axis. So it's going to is minus 1. There you go. So this is f of minus of x, if that's y equals f of x. And then finally we're going to reflect it. So the asymptote is still the y-axis, but this part will stay above. So this part will have to be reflected like this. So let me redraw it neatly. So the y-axis remains the asymptote. The crucial point is there, minus 1. You will have that part, which was the slow growing part over here, slow growing part over here, and then this part at the bottom is reflected. There you go. Now you can have a go at exercise 2F.